Here are the instructions for graphing rational functions. The first thing you need to do is to factor your function to find the restrictions. Then identify if the restriction is a whole or an asymptote. Create a table for your rational functions. Place the wholes and asymptote on the graph first, and then draw in the rest of the graph. When you draw in the rest of the graph, make sure that you include any discontinuity, that you don't cross over any asymptote or cross through any holes. Here's an example of a rational expression that's going to have a whole and an asymptote. So we start off with 4x minus 12 over x squared plus x minus 12. First, we factor in order to find the restrictions. The restrictions are at positive 3 and negative 4. We're going to cancel out any factors that we can and simplify. Y equals 4 over x plus 4. The discontinuities for this function: the horizontal asymptotes are at 0, the vertical asymptote is at x equals negative 4. We have a whole at x equals 3 because it cancels out from the original problem, but to find the location of the whole, we plug x equals 3 into the simplified function. The y-coordinate that goes with the x-coordinate is 4 over 7. So the location of the whole is 3, 4 over 7. Then we're going to make a table for the simplified form. We're going to make the table just like we did yesterday by starting off with 4 over x and then shifting all of the x points to the left 4. When I graph, I'm going to place the discontinuities on the graph first. So that means my horizontal asymptote, my vertical asymptote, and the whole. A whole on the graph is indicated by an open circle. And then I plot all the points and connect my curves. Make sure that you don't cross through the whole at 3, 4 over 7. And make sure you don't cross through your vertical or horizontal asymptote. Here's an example where we're going to end up with 2 vertical asymptotes. We have x plus 3 over x squared minus 6x plus 5. We factor first to identify the restrictions. The restrictions are x equals 5 and x equals 1. In this situation, nothing cancels out, so that means both of the restrictions are going to be vertical asymptotes. Our horizontal asymptote is going to be at 0 because the power of the numerator is x, the power of the denominator is x squared. Since the bigger power is on the denominator, our horizontal asymptote is at y equals 0. And then our vertical asymptotes are x equals 5 and x equals 1. When we make a table for these guys that have 2 asymptotes, we're going to need a few more points because we need to see what happens before the first asymptote, in between the 2, and after the last asymptote. So for my table, I'm going to plug everything into the original equation because nothing canceled out. The x values I used were negative 1 and 0, skipped over x equals 1, that's my first asymptote. 2, 3, and 4 are the points that happen in between x equals 1 and x equals 5. I skip over x equals 5 because that's my next asymptote. And then I finish the table with 6 and 7. And again, I plug in the x values into the original equation, x plus 3 over x squared minus 6x plus 5. And then the steps are the same for graphing. We start with our asymptotes first. Horizontal asymptote at y equals 0, vertical asymptotes at x equals 5 and x equals 1. And then I plot my points and make sure that we don't cross through the horizontal or vertical asymptotes.